There we go. I think we're there and ready to go. So yes, the presentation really is around SD WAN. There's been a lot of differing messages, I think, around the technology that underpins all of the elements that we'll be talking about today. It is really the concrete roads that everything is delivered upon. And therefore, SD WAN over the last few years has become quite a popular term, and this is hopefully to kind of demystify some of that speak from different vendors, from different VARs, from different service providers. And is it the death knell for MPLS? And we'll step through that. So, we love acronyms as a business, as a sector. If we can put it into an acronym, we would much rather do that. So really, just for those who may not know, obviously WAN, wide area network, that is truly a collection of computer devices, a building connecting to another building, and that kind of thing. MPLS, that's really been the de facto way of enterprises communicating over vast distances, and it stands for multi-protocol label switching. SD-WAN, popular parlance, software-defined wide area network, and another one that we will come across is ATM, asynchronous transmission mode. There is no test at the end of this, so you don't need to remember them. I'm not going to test you at the end. But as I say, there is a huge amount of acronyms that are thrown around, especially by technology vendors, by technologists who make an assumption that everybody knows about them, but they don't always. So they're the kind of things that we will be talking about through this presentation. But let's start off with some history of how wide area networks came about. So we go back to the 70s, a great decade, not just because it was the one in which I was born, but also it launched various things that what we now take for granted all came from. So one of the key things really was around the packet switch network, or PSN. So that started in the 70s. It was a type of communication that computers would use to talk to each other. There were others as well that were launched. The token ring, for example, created by IBM. Great technology. Your computer couldn't talk on the network unless it had that token. So it's a bit like when you're at school and the teacher would say you can only speak when you've got the speaking stick. And interestingly enough, packet switch network has been the one that has sustained throughout all of the decades. But at the time, by computer scientists, was the one that they said would never last, would be the one that would fail. And IBM, inventor of token ring and that kind of thing, said, that was going to be the technology. So, you can never quite, tell what's going to happen around that. But the packet switch network then gave rise to what some may know when I say ARPANET. So ARPANET was devised and created by the US military, and it gave birth and rise to what we now know as the internet. A great advancement in the way that road is built to allow computers to talk to each other. So ARPANET then, interestingly, in the 70s, allowed for the first email to be transmitted. So it all comes through that innovation, and that, as Alexandra said, that continual drive for change and that continual drive for innovation. So we moved through the 70s, and we had the birth of ARPANET, we had the birth of the packet switch network, and it was around just before during the 80s that we then started to see enterprises wanting to connect a group to another group. So we had the X25 protocol, the T1E1 circuits, allowing for that cross communication with speeds up to 1.4, 1.5 meg. Wow, that was speedy. And then we move into the early 90s, where we then start to see those speeds becoming greater and greater. With the development of new protocols such as frame relay, which gave whopping speeds of up to 45 meg. So we've really kind of gone from nothing, where there was with the X25 protocol, where the speed was up to, bearing in mind, up to 1.5, and now we're into the early 90s where it's at 45 meg. And then as we move through the 90s, frame relay, because it didn't really kind of offer things like QoS and packet prioritization and those kind of things. So we then start to move into ATM, asynchronous, the asynchronous transfer mode. And that gave us much greater speeds as we move through the 90s. And we left the kind of Britpop era behind, and we started then to go into the early 2000s with the birth of MPLS, so the multi-protocol label switching protocol. And that then was the key one that was adopted by enterprises to deliver that wide area network again. So connecting hubs into headquarters and those kind of things. And then it wasn't really until the early 2010s that we then start to see SD WAN coming out onto the streets. And it was really driven, I guess, by the greater adoption of public cloud services, and where we have that hybrid of private cloud, things still stored within the enterprise network, and more services being consumed in the likes of, say, Office 365, and the transition to public cloud services. So MPLS, SD WAN. As I say, MPLS is known as the multi-protocol label switching. It's tried and tested technology. What we had today is 20 years, 2 decades of development, of use, and it's known for its reliability and performance. It uses physical circuits to create that kind of hub and spoke environment where remote offices connect into the central headquarters. So it's very, very secure. It's very, very reliable, and you kind of know what it is you're getting. If you've got a 100 meg circuit connecting, site A into the headquarters, then that's what you've got. So why would we look at introducing a newer technology? If MPLS allows all of that, is reliable, is secure, offers great performance, why would we look at developing something new? Surely you would just add more into MPLS. But as I say, with the consumption of cloud technologies, with the differing types of circuits and connectivity, so with not just Ethernet circuits, but you have broadband circuits, and now with 5G, those 4G and 5G circuits, it offers more flexibility around how you connect to where it is you're consuming services from. So SD-WAN really allows you to do that. It allows you to take advantage of of the connectivity that you have. It may be a blend of a fixed Ethernet circuit into the headquarters. It might be a broadband circuit into the internet, and it gives you that that flexibility and choice, so that if you're consuming a cloud service, you can take that and you can just go out onto the internet into that cloud service, obviously, you know, with security in mind and zero trust and those kind of things. But it saves then you having to route packets into the core enterprise, only then to break out onto the internet to go to that cloud service that you're consuming. So MPLS, as I said, is tried and tested. You know, it's now got decades behind it, and it was revolutionary at the time because with the PSN, it routed based on destination and you know, took that packet, passed it to a router. That router unpacked it, looked at what was needed, packaged it up, and then sent it onwards to the next hop, or if that was the destination, to that destination. So MPLS revolutionized that by introducing what's called packet labels. So instead of the router now having to unpack the data packet and look at, well, where has it come from and where is it going? It just now needs to read that label. So it's a bit like a you know, a post office. You know, you post a letter, you write the address on it, it then sends that, you know, and it goes through the different hubs on the post office routes until it gets to its destination. The postman, they don't have to keep opening up the envelope, looking at the address inside, and then putting it into a new envelope and repackaging it. So it really did transform how that technology, how enterprises used wide area networks. And again, it employed fixed connectivity in that kind of hub and spoke environment. So it was very kind of reliable. It was, you know, it offered that performance because you had fixed bandwidths and, you know, you had fixed SLAs on those circuits. So it was very, very reliable. And again, it was highly scalable. You know, you can add in hubs as and when you need to, you know, and therefore it allowed for a reduction in network congestion. So, as I say, MPLS are really kind of, when you think of what had gone before with ATM, with frame relay, you know, it really was transformative in what it was doing. But again, you know, with SD WAN, when that came along, it lowers the complexity. You know, it allows you to have that central piece of configuration that is then pushed out to your hubs, so that instead of engineers working tirelessly managing the hubs, programming the hubs, so that they, as individual entities that then connect into the WAN, SD WAN allows you to have a template that you push out, and it's done centrally. It enables public cloud usage without the need of having to run through your core network and through your core enterprise. So it can utilize the internet circuits that may already be at that site. You don't then have to deploy fixed circuits just to connect that hub into your enterprise. Its ability to self-manage, you know, the likes of Cisco, for example, you know, their SD WAN solutions are really around self-management, are about that democratization of complexity. And it just allows you to be more self-sufficient, to be more agile in the way that you do things. And it allows you then to fast start your projects. You know, if you don't have to wait 90 days for a circuit to be put in on a good day, you know, if there are no way leaves or anything like that to be done, you know, and there's already a circuit there, and you've consumed that company into your enterprise, then it allows you to onboard them within minutes. So it's around, with SD WAN, it is around that lowering of complexity, allowing you to use the mediums that are necessary for your business, and to give you some self-management. So with SD-WAN, it's less about, if we think about the question, it's less about will SD-WAN kill off MPLS? SD-WAN sits on top of everything else. It's software defined. So it's not a fixed circuit. It's not about, it's not sits on layer 2 or layer 3. It sits, above all of that. So it sits as an overlay on top of your existing WAN. So you can have an MPLS WAN that you then, if you've financially invested in, you don't necessarily need to rip it out and put in an SD-WAN. So again, SD-WAN, it virtualizes the network functions. It doesn't, it means that you're not having to run on common hardware. You don't have to have that piece of technology that is common within your enterprise and then roll that out to new sites, and then have an engineer configure that piece of technology and then add that piece of technology to a fixed circuit if it's already there. So if we continue the SD-WAN versus the MPLS discussion, SD-WAN allows for allows you to think less about geographic boundaries. You don't then have to think about well, what are the controls that may be in the US, for example, that we'll need to take up. Around the types of technology that are available in that country, because it allows for you as a customer to choose the path that packet goes down. It gives you much more flexibility in the way that it allows for that. But the other key benefit that SD-WAN would bring you is it's that centralization of security. The security is obviously key for any enterprise when connecting sites and services, and whether that is a public cloud service or whether that is through a private service, you want to make sure that you're implementing that zero trust policy across all of your sites. So having that centralized piece of work, that centralized way and methodology of delivering zero trust security out to those sites that you're connecting in is a really, really key benefit. You don't then have to have policies for different sites. You don't have to have different policies that are generated bespoke for different sites and then applied to that site locally. You can have it created centrally and pushed out. So when that site then does that initial kind of phone home back to the enterprise, it then gets that policy delivered to it, which makes it fundamentally more efficient in the way these sites are onboarded, and a much less opportunity for errors to creep in, and because you're not designing everything as if it is the first time. So, I mean, WAN evolution is inevitable, regardless. And as we started, SD-WAN, the death knell of MPLS, inevitably something is going to replace something else. And whether it is built, built on top of that, or whether it is something radically new, doesn't really matter. MPLS, will at some point, move aside in the same way that frame relay moved aside, and I bet there are still, some IT directors out there who stand firm on their decision to stick with frame relay when MPLS came out. So it really is an inevitability that technology progresses, innovates, as we've talked about through Alexandra's presentation. Innovation is inevitable, and more so now because of the way with COVID-19 and the way now we consume more services from the public cloud. SD WAN has become a lot more of a hot topic. It's much more of a way that companies are seeing the benefits from that flexibility, from being able to look at what they do and give them that choice. They don't have to rip out their MPLS network and replace it with an SD WAN. It's a slow evolution. You can start to bring in some of the SD WAN elements and overlay it on top of what you already have. What it does do, though, is it allows you for the future, when you onboard new sites or you open new offices and you want to connect them into the enterprise, it gives you that easier flexibility to be able to do that. So I've talked a lot about SD WAN and the flexibility that it brings. Obviously, with SD WAN and various other pieces, it will itself find at some point that its flaws will drive further evolution and further ways to drive that innovation on the way that we connect various things. So, there's something new. As we write this, there's always something new. With SD WAN, its flaws has allowed something called Secure Access Service Edge, or SASE, to start to peek its head up and say, well, actually, your flaw, I've fixed that. So, but that's a topic for another time. But it does show that innovation is constant, even in this world, where typically when a technology takes hold, it takes hold for decades. But with the rate of change of how we consume services, whether that's through, as I say, a private cloud, a public cloud, the rate of change determines how quickly that innovation comes around. So from Britannic's perspective, we really have invested a huge amount over the last nearly 40 years of being in existence. And, we are now truly one of very few partners, technology partners, managed service providers, value-added resellers, systems and service integrators, and development houses that have a true knowledge of all things to do with communication. We've built our own technology platform, and that technology platform sits on top of our core network, our core wide area network that can overlay things like SD WAN, MPLS, VPNs, all of those kind of technologies on top of our core underlying network. We've made sure that we're future-proofed in what we can deliver by having unrestricted dark fiber links connecting our 3 DCs. So, and then within those DCs, we're interconnected with all of the tier 1 carriers. So, we've got 10 gig NNIs into the likes of BT Wholesale, Virgin, Expo-E, Vodafone, so that we can truly deliver end-to-end services to our customers and our partners, because we don't just hook in our customers, we also hook in our partners, like Five9, for example. They're connected into our SIP platform, which is NetX2. We also have interconnects with all of the public clouds, so Amazon Web Services, Azure, and Google Cloud, so that you can connect your WAN, or you can build your WAN within our core infrastructure, and you can have that public cloud and private cloud, that hybrid experience. So we've built our core network really to be supercharged, I guess is probably the right word, because it's built for performance of real-time applications. We built our credibility over 40 years on delivering voice to our customers, real-time applications to our customers. So our core infrastructure, our core network needs to be built with that in mind. It needs to be able to deliver that performance to our customers. And that's either in a public cloud or a private cloud experience. So, we need to, as a company, look forward. We've built our technology so that we can have those conversations without fear of having to re-architecture, redesign, redeploy, and it's a continual evolution. So when it comes to SD WAN, we can deliver through our partnerships with the likes of Cisco, whether it's Cisco pure SD WAN solution or whether it's the Cisco Meraki public cloud solution. We have those partnerships in place. We have those relationships in place. And then through, as we heard previously, our innovations hub, that will allow us to grow strengths in areas that are important to you, but also make sure that, we're bringing those changes, those innovations to you as customers. I think as Henry Ford once said, if he'd have waited to, or if he'd have asked his customers what they wanted before designing the car, they would have just said a faster horse. So, it is key for us as well to bring innovations to you and have our infrastructure ready to allow for that innovation. So is MPLS ending? Is SD WAN the death knell for MPLS? No. No. Evolution is gradual, isn't it? As we've seen, especially in this area. Innovation is driven by consumption and how people want to consume. There will come a time where MPLS will fade away because there may not be a need for a true WAN built on MPLS. But there will be a place for it, and as I say, with SASE coming hot on the heels of SD WAN to deliver that kind of blended version of SD WAN next gen firewalls, we're then seeing, that consumption again by consumers is driving that innovation around what we do. So that's really the end of this presentation. I think, for me, the key thing is around flexibility. The birth of SD WAN, we're seeing it more so now than previously, is because of the flexibility that it brings, because people are, or enterprises are seeking that flexibility, not just around how it's implemented, but also about how it's maintained, about how its benefits can be used in terms of the consumption of what services they now have. And that's that. I open it up to any questions.
Thank you, Andrew. So just checking the chats, seeing if there's any questions come in. That's an interesting one. The 70s WAN and Bowie. So a trip back through the decades there, Andrew,
Exactly.
to some of the earlier technology.
Absolutely. The birth of flares and disco. There you go.
Indeed, indeed. So do you think the pandemic has accelerated the focus on SD WAN and new networking technologies?
I think so. I would definitely say yes, it has. The fact that the pandemic has fast forwarded even innovation. As you opened with your slide there and your quote from Satya from Microsoft, it has supercharged the innovation processes. I think to allow people to be more forward thinking in what they deliver. They don't have to now think, oh well, this can be a 5-year project. They're now looking at, well, how we've done this piece of innovation and we've enabled our workers to become hybrid. How do we then take that piece of technology that is still in the old world of hub and spoke, fixed circuits, A is B and nothing can go between them. How are we more flexible? How can we add that flexibility in our hub and spoke and our enterprise environments?
And do you think, or what changes do you think will come with the advent of things like 4G and 5G? What sort of change and impact and opportunity does that present to businesses?
So I think one, I think the big change around circuit technology is going to be on the flexibility that it brings. So with 4G and 5G, it will come down to how quickly can it be deployed and how much is it going to cost, and how secure will it be once it's there. So I think with 4G and 5G, 4G, we've had that around. It's been used as a backup for some of our customers on their circuits. So they'll have a fixed circuit with a 4G backup. So it's been there. But it's always been seen as a backup. You wouldn't run your business necessarily on a 4G circuit, but with 5G, with greater speeds and greater uptake, it can almost run your business on it. And you don't then have to have, that way leave done or that 90 days to have a circuit, delivered to your building. You can have, a 5G ready router delivered, configured, it phones home, and that through the SD WAN, it then gets its configuration and it's up and running within, minutes as opposed to weeks.
And I think certainly as the diagram depicts, the change in how people are consuming technology and services will have a fundamental difference on the design and delivery of networks. So blending in public cloud solutions and hosting with maybe some potentially some on-premise or private cloud or data center environments. So I think that level of flexibility is going to be required moving forward.
No, definitely.